So today we're going to learn about geometric sequences. But first, let's review what we already know about sequences. We already learned about arithmetic sequences. Arithmetic sequences. And arithmetic sequences are sequences that add by a fixed term. Now, of course, remember, subtracting goes along with that. Because if you subtract a number like 2, it's the same as adding -2. So arithmetic sequences add or subtract. So geometric sequences multiply. Now, notice the word geometric does not have an A like arithmetic does, but it does have an M. So this will help us remember geometric multiplies. For example, let's take the sequence 1, 3, 9, 27, and so on. To get from 1 to 3, you multiply by 3. Isn't 3 times 3 9, and 9 times 3 27? So notice, to get to the next term each time, we multiply by 3. This is an example of a geometric sequence. Let's take some note. A geometric sequence is a pattern that is formed by multiplying a fixed number to the previous term. Let's write multiply. Pause the video and write that in your notes. Now let's look at examples A, B, and C and see if they are geometric or not. First we have 1, -5, 25, -1, 25. Let's ignore the positive negative sign for just a moment and look at just the numbers. We already know that 1 times 5 would be 5. 5 times 5 is 25. And of course 25 times 5 is 125. So far, just the numbers do give us times 5 over and over. Well, how do you think we're going to get from 1 to -5? If you said make 5 negative, you are correct, because a positive 1 times a -5, ow, my eye, I'm very sad. That's a negative thing, giving us -5. Now, that -5 times -5 gives a negative times a negative. Oh, look, he's streaming. He's so happy. That's a positive thing for a positive. So now I take that positive and I multiply it by a -5. Ow, my eye, I'm sad. That's -125. So anytime you see the positive, negative pattern, it's going to be multiplying by a negative number. So, is this an example of a geometric sequence? Yes. Now let's look at example B. 1, 3, 6, 18, 36. Pause the video and see if you can find the pattern. Okay, let's check it out. What do you multiply by to get from 1 to 3? 3. What do you multiply 3 by to get to 6? If you said 2, you are correct. How do you get from 6 to 18? Times 3. And 18 to 36? Times 2. So this is definitely a multiplying pattern. Times 3, times 2, times 3, times 2. But is it geometric? No, it is not multiplying by a fixed number. It's not multiplying by the same number over and over. So it is not geometric. Let's check out example C. 64, 16, 4, 1, and 1/4. Again, pause the video and see if you can find the pattern. I hope you discovered that this pattern is dividing by 4. Let me write that to the side so we can talk about it. Now, it's easy to see right here. 16 divided by 4 is 4, divided by 4 is 1, divided by 4 is 1/4. Okay? Now, wait a second. We're looking for geometric multiplies. We're looking for multiply patterns. So my question is there a way to write divide 4 as a multiply problem? The answer is yes. Because think about it. If we were to make this into a fraction, when you divide fractions, you don't ask why. You just flip the second one and multiply. So dividing by 4 is the same as multiplying a fourth. And think about it. When you're dividing by 4, aren't you finding a fourth of something? So let's check it out. 64 times 1/4 is 16. 16 times 1/4 is 4. Every single time we're multiplying 1/4 to get to the next term. So this is geometric because you can multiply by the fraction 1/4 to get to the next term each time. All right, let's look at another term called the common ratio. Now, all that means is the number being multiplied over and over. Let's write that down. We represent the common ratio with the letter R. Let's go back to examples A, B, and C and write the common ratios. What did we multiply over and over on example A? -5. So for this one, R equals -5. For example B, was there a common number being multiplied? No, there is no common ratio for example B. That's supposed to be an R. Example C, what is the number being multiplied over and over? It's not 4. It's 1/4. So for example C, R is 1/4. Now, let's refresh about rules. A rule is simply a variable expression used to describe the sequence, and we use n to represent any number in the sequence. For example, let's look back at example A. No matter where I am in the sequence, we'll call that n. What math do you do to get to the next term? You multiply -5. Now, some people may want to write it like this. N times -5. But remember, there's a better way to write multiply. So let's write it this way. We're going to squish them together with no dot in between. But remember, the number has to be in front of the n. It's called the coefficient. Example B had no common ratio, so there is no rule. Example C, no matter which term you're at, you multiply 1/4 to get to the next term. So remember, the number goes in front of the variable n. So we're going to write 1/4 n. Now let's go down and do example D together. Find the next 3 terms and then write the common ratio and rule. Here we go. 100, 10, 1, 1/10, and so on. Pause the video and see if you can find the pattern. Now at first this looks like a tricky pattern to find because the numbers start very large, but if we look over here, you can see to get from 10 to 1, we're going to be dividing by 10. From 1 to 1/10 is dividing by 10. You can even see it looks like 1 divided by 10. So you hopefully figured out that example D is a dividing by 10 pattern. But remember, geometric sequences multiply. So let's make sure and write it as multiplying sequence. Dividing by 10 is the same as multiplying what? Hopefully you remembered that all you have to do is take the reciprocal. Okay? Dividing fractions, don't ask why. Flip the second and multiply. So instead of dividing by 10, it's the same as multiplying by 1/10 because it's finding 1/10 of the number. So 100 times 1/10 gets us 10. 10 times 1/10 gets us 1. And the multiplicative identity property says 1 times 1/10 gets 1/10. Let's keep going and see if we can find the next 3 terms. I'm going to use the space on this side of my paper to do just a little bit of work. A lot of people see fractions and they get scared, but there's nothing to be scared of. If you take this number that we're left with right here, 1/10, and I multiply it by 1/10, multiplying fractions, no big problem. Top times the top, bottom times the bottom. Top times top gets us 1. Bottom times bottom gets us 100. So, right now we have 1/100th. Let's take that 1/100th and multiply it times 1/10. Again, top times top, bottom times bottom. So now we've got 1 1/1000th. And I take 1/1000th and I multiply it by 1/10. I'm running out of space, but that's okay. And now I add another 0 on, and I've got 10,000 in the denominator. 1/10,000th. All right. Now, those of you who are calculator people, let's just prove our math really quick. Here we go. 1/10, I'm going to divide it to see what decimal that is. 1 divided by 10. 0.1. That makes sense. So if you want to prove it with a calculator, you just take it and multiply by 0.1. Okay, let's get the calculator back up and do that. 1/10 times 1/10 equals tenths, hundredths, 1/100th. Look, it matches. Again, let's do times 0.1, tenths, hundredths, thousandths, 1/1000th. It matches. Let's take that and multiply it times 0.1 equals tenths, hundredths, thousandths, 10,000ths, 1/10,000th. It matches. All right, this was successful. Now, the common ratio is the number being what? Multiplied. What did we multiply over and over? 1/10. So R equals 1/10. And finally, the rule is where we write it with the variable n. So let's just write 1/10 n.